Imagine staring deep into the universe and finding something that shouldn't exist. A galaxy, massive, ancient, spinning in the cold silence of space. But it breaks the rules. It defies everything we thought we knew about physics, gravity, and even the creation of the cosmos itself. Because this galaxy has no dark matter. That's right, the invisible glue that's supposed to hold galaxies together. The mysterious force that makes up over 85% of the universe's mass. Gone. Absent. Missing. This isn't just an anomaly. It's a cosmic rebellion. If this galaxy exists without dark matter, could we be wrong about everything? Or worse, have we misunderstood the very fabric of reality? Welcome to a journey beyond scientific boundaries, where one strange galaxy threatens to unravel the cosmic code. Buckle up. What you're about to hear will challenge your mind, and may permanently change how you see the universe. In the vast, silent void of the universe, galaxies shimmer like jewels scattered across black velvet. Each one spins, held together by invisible forces, bound not just by stars and gas, but by a mysterious element scientists call dark matter. Or so we thought. Because in 2018, something incredible happened. Astronomers spotted a galaxy that shouldn't even exist. A galaxy that defies the very framework of modern astrophysics. Its name, NGC 1052 DF2, or simply DF2. At first glance, it looked ordinary, maybe even boring. A faint, ghost-like structure floating about 65 million light-years away, in the direction of the Cetus constellation. It didn't have the glowing spiral arms of the Milky Way. No bright bursts of star formation, just a diffuse, almost transparent blob of stars. But when scientists looked closer, the universe whispered a secret that would shock the world. Using the Hubble Space Telescope and the Keck Observatory in Hawaii, astronomers began to study how the stars within DF2 were moving. Their motion held the key to something vital: mass. Because in galaxies, stars don't just drift, they orbit. And the speed of their orbit tells us how much gravitational pull is acting on them. And by extension, how much mass is present, even the invisible kind. In almost every galaxy we've observed, these stars move faster than expected. Why? Because something massive, but unseen, is pulling on them. That's what we call dark matter. But DF2, the stars moved at normal, gentle speeds. Not too fast, no extra pull, as if what you see is all there is. That was unthinkable. A galaxy without dark matter. It was like finding a planet without gravity, a fire without heat, a heartbeat without blood. Dr. Peter Van Dokkum, lead astronomer from Yale University, said it best. This galaxy is missing the thing that we thought was essential to make galaxies: dark matter. He and his team measured the motion of 10 bright star clusters inside DF2, basically giant balls of stars orbiting the galaxy's center. Their velocities were slow, far too slow to indicate the presence of dark matter. And when the mass was calculated, the results were shocking. DF2's total mass almost perfectly matched the mass of the stars alone. No invisible mass, no extra weight, no sign of dark matter. Suddenly, one of the biggest assumptions in modern cosmology began to crack. Because if this one galaxy could exist without dark matter, how many more might be out there? Was this a cosmic mistake, an illusion of distance or technology? Or was this the first real sign that our understanding of the universe, our physics, our models, our theories, might be fundamentally flawed? Whatever the answer, one thing was certain: DF2 had become the most controversial galaxy in the cosmos, a ghostly rebel in a universe governed by invisible laws. And its silent defiance had only just begun. Why this breaks physics? To truly grasp the magnitude of DF2's mystery, we need to understand why its existence is so shocking. Because dark matter isn't just an interesting side theory in physics, it's the backbone of modern cosmology. You see, when astronomers observed galaxies over the past century, something strange always emerged. Their stars rotated way too fast for the amount of visible matter they contained. Galaxies should be flown apart under the pressure of their own motion, but they didn't. They held together as if some unseen force, some hidden mass, was gluing everything in place. That invisible glue was named dark matter, an unknown substance that neither emits, absorbs, nor reflects light, but gravitationally affects everything around it. According to our best models, dark matter makes up about 85% of all the mass in the universe. That means all the planets, stars, gas clouds, black holes, you, me, everything we can see is only 15% of reality. The rest, invisible, but powerful. And now, DF2 has thrown a wrench in the gears. Because if DF2 truly contains no dark matter, it shouldn't exist in its current form. Its stars should be flying away from each other, slowly dispersing into the cosmic dark. Without that hidden mass to hold it together, gravity would lose its grip. But DF2 is stable, balanced, peaceful, almost like it's following a different set of rules. This raises terrifying questions for physicists and cosmologists. Have we been wrong about how gravity works? Is it possible that dark matter isn't as universal as we believe? Could gravity behave differently in low-density regions of space? Or is dark matter not real at all? Could it be a placeholder, a patch, added to equations that we don't fully understand? The implications are enormous. Entire simulation models of the universe's birth and evolution rely on dark matter to form galaxies, clusters, and large-scale structures. If galaxies can form and survive without it, then perhaps our cosmic blueprints are incomplete or even broken. Some scientists have even started revisiting alternative gravity theories to explain what DF2 is showing us. Because if one galaxy doesn't follow the rules, maybe the rules were never as universal as we thought. And if that's true, then DF2 might not be the outlier. We might be. The controversy and pushback. DF2 didn't just raise eyebrows. It sparked a storm. Because in science, one anomaly doesn't just rattle ideas, it shakes entire institutions. When the discovery of a galaxy with no dark matter was first announced, many scientists refused to believe it, not out of stubbornness, but because it contradicted decades of data, observations, and models that had withstood every test. The first wave of criticism: distance. Several researchers argued that DF2 was not actually 65 million light-years away but much closer, maybe 42 or even 40 million light-years. Why does that matter? Because distance determines how big and how massive an object appears. If DF2 were closer than we thought, its stars would be less massive, its total mass would shrink, and then, suddenly, the galaxy might seem to lack dark matter. But in truth, it would just be a trick of perspective. So astronomers went back to the data. They re-examined brightness, redshift, and surface properties. They debated the quality of the Hubble measurements. And while some scientists insisted the galaxy's distance was overestimated, others remained firm. One of the strongest rebuttals came not from argument, but from evidence. Because just a year later, another galaxy was found, nearly identical to DF2, and it too appeared to lack dark matter. This second galaxy was named NGC 1050 to DF4. Same region, same structure, same behavior. Now it wasn't just a fluke. This was a pattern. A one-time anomaly could be dismissed, but to galaxies, discovered using different data sets, telling the same story, that demanded attention. Yet, the debate only deepened. Were these galaxies born this way, or was their dark matter stripped away? Some theorists propose that DF2 and DF4 may have passed too close to a much larger galaxy, possibly NGC 1052, their cosmic neighbor. In that violent interaction, tidal forces might have pulled their dark matter away, leaving only stars behind. A cosmic theft. But then why don't we see this happening more often? Why are DF2 and DF4 so unique? Others doubled down, claiming the measurements must be flawed, or that the galaxies are in a temporary, unstable state. Some even suggested the data could be optically deceptive, that what appears to be one galaxy might actually be a superposition of two. The tension wasn't just scientific, it was philosophical, because if DF2 and DF4 are truly dark matter free, then something is wrong, either the measurements or the model. And when faced with that choice, the scientific community split in two. One side demanded more proof, more data, more galaxies. The other whispered a quiet question: what if dark matter isn't what we think it is? And in the quiet vacuum of space, DF2 and DF4 drifted on, two silent rebels, igniting a firestorm on Earth.